The California Science Center outside the Air and Space exhibit. And this is the space capsules. Project Apollo grew out of President John F. Kennedy's famous speech calling for the United States to land a man on the moon and return him safely to Earth before the end of the 1960s. Apollo command modules carried 3 astronauts from the Earth to lunar orbit. Once in lunar orbit, 2 astronauts transferred to a lunar module not displayed here that separated from the command module and carried them to the lunar surface. On return from the lunar surface, the lunar module docked with the command module. Then the 2 astronauts re-entered the command module for the trip back to Earth. The Apollo command module on display here was originally built to go to the moon as Apollo 18 when Congress cut funding for the Apollo program. Its mission was changed to the Apollo-Soyuz test project. This is the original Gemini 11 space capsule flown by astronauts Charles P. Conrad Jr. and Richard Dick Gordon Jr., which went into space on September 12, 1966 and returned September 15, 1966. We've removed one of the doors so you can see inside, and we encased the capsule in plastic for protection. As you can see from the capsule, the astronauts didn't have much room to move to stand. They had to shoot up and open the hatch first. The 2 astronauts lived together inside this capsule for almost 3 days, eating 3 freeze-dried meals a day, getting rid of waste with hoses and bags, and sleeping weightless in the 10 people all around the Earth. The Gemini space capsule is built to fly. Look for the round holes that circle the nose of this capsule. Those holes held thrusters. With these and other thrusters, Gemini astronauts could literally fly circles around a target. Gemini 11 landed on autopilot only to test the landing system. What was Project Gemini? Project Gemini sharpened the skills needed for the Apollo program with precision. Flying astronauts could reverse, dock, and maneuver in orbit. Longer flights and targeted re-entries also helped us for the moon flights. This is the Chandra Space Telescope. Chandra orbits Earth to look at high-energy X-ray light from stars and galaxies, light that can't go through our atmosphere. Chandra is as long as a big trailer. Our model is 1/5 scale. Chandra's overall orbit goes more than a third of the way to the moon. Chandra is one of NASA's 4 great space observatories, one each to look at the sky in X-ray, gamma, infrared, and visible light. X-rays don't reflect off a mirror the way normal light does, so mirrors used in the X-ray telescope need an unusual shape. Chandra's moon mirrors look a bit like glass barrels. Incoming X-rays glance off the insides of the barrels and focus to a point. This is the Hubble Space Telescope. This model of the Hubble Space Telescope is 1/5 scale. The real one orbiting Earth now is the size of a school bus. Data from Hubble has helped astronomers measure the age of the universe and peek into the gas clouds where young stars and planets are born. Why put a telescope into space? Because an orbiting telescope rises above Earth's atmosphere. In the atmosphere, light gets bounced around. That can blur images taken by telescopes on the ground. Hubble can get sharp, detailed pictures of distant stars and galaxies, free of twinkling we see on Earth. This is the Apollo Command Module spacesuit. Apollo Command Module pilot Thomas K. Mattingly wore this spacesuit during the Apollo 16 lunar mission. It's designed to protect the astronaut from the high-energy radiation of the sun, extreme changes in temperature, and micrometeoroids. The spacesuit has 21 layers and weighs 185 pounds on Earth. The astronauts' life support system is contained within the backpack, which provided enough oxygen for 8 hours. The spacesuit's one-piece liquid cooling and ventilation undergarment contains about 300 feet of plastic tubing. All functions of the suit are monitored and controlled from a control board mounted on the chest pack. The spacesuit is displayed with the helmet removed in order to provide adequate air circulation to help preserve the suit. These are the helmet and gloves that go with the Mercury suit. At the Endeavor, California Science Center.
Okay, I'm sorry.
The runway, space shuttle tires took a lot of pressure from orbit to landing. The shuttle tires weather temperature changes of up to 170 degrees Fahrenheit and a drop in altitude of over 200 miles in less than an hour. Altitude and temperature spring changes in air pressure, which could have caused tires to leak or burst if they weren't designed to meet the challenge. Like tires and most aircraft space shuttle tires were filled with nitrogen. Nitrogen works better during altitude and temperature changes than air, which is made of 21% oxygen. Nitrogen also resists fire since the molecules are bigger than oxygen. Nitrogen leaks out from tires more slowly, which is a big plus in a vacuum of space. Electricity on the space shuttle orbiters came from fuel cell power plants. The orbiters' fuel cells generate electricity from chemical reactions using hydrogen and oxygen instead of the pollutants left behind from burning gasoline or other fuels. The only leftovers after the chemical reactions were water and heat, both of which came in handy on the shuttle for other uses. This fuel cell power plant used on Endeavour produced several kilowatts maximum continuous power, that's enough to power 115-60-watt light bulbs at a time. Each orbit had 3 fuel cell power plants on board for every mission, where 2 would have generated enough energy for the orbiter alone. The third made sure that enough electricity was produced to power payloads too. Recycling leftovers. One of the leftover products from the chemical reactions in the fuel cells, water, was as helpful to the astronauts as the electricity. The water produced when the hydrogen and oxygen combined could be used for the crew to drink or to rehydrate food in the gallery. The orbiters could also leave extra water from the fuel cells to supply the International Space Station, which was much less expensive than transporting water from Earth. Monday officially began Orbiter Vehicle 105, later known as Endeavour, the nation's fifth space-worthy shuttle and the newest of the fleet, as with all Orbiter's parts of OV-105 were constructed all over the country, but many MS components such as the crew compartment and fuselage were manufactured in California. Pieces came together in Palmdale, California, where workers at Rockwell International assembled tested
surprised how California was as well. We actually have a dog on board. A bit like a camp trip, it's always this fluid experience that allows you to see what happens to the space. Microgravity space will tend to assume some minimal energy level in the sphere. That's the science part of it. The fun part of it is watching a bunch of grown men trying to play with bubbles of fluid in zero gravity.
Various nonlinear fluid mechanics, physical elastic properties are important in space. Thank goodness many of the science experiments are chemicals.
Systems on board, so providing electrical power. operator system providing coolant to all of the avionics equipment aboard the vehicle. Traveling into space on the forward flight deck is Commander Mark Kelly and pilot Greg Johnson. Between and behind them is flight engineer Roberto Vittori. Rounding out the flight deck was Mike Network regional number 2 international realized all three are forming as planned. Down on the mid-deck down Westo and Greg Chantal. Westo headed to the International Space Station for the first time. Vittori and Fink making their first voyage on the space shuttle. Flying to the International Space Station aboard the Soyuz spacecraft.
originally built by Rocketdyne in Canoga Park, California. Plus we have 3 at the back of the shoulder and system burned because from the water. Orange extras and on the
Boy, this is exciting. They should get
We're in the space shuttle Endeavour building.
Shuttle Endeavour.
benefited from a rich history of human spaceflight in the United States. First came Project Mercury, which tested humans' ability to survive in orbit space. Project Gemini developed a perfect antenna suit to the space shuttle, the world's first usable space vehicle, took space travel in a new direction. It helped humans keep their presence in space for 30 years and brought others into orbit. We wanted the astronauts not to be really test pilots, though many were. The shuttle carried scientists, engineers, doctors, and educators. Many were early nations, college, and kids for the orbit, making history and encouraging international cooperation. The shuttle belongs to all of us. Program included 6 orbiters, 5 that flew in space, and 1 that devised useful test flights in Without putting on spaces. On some missions, two modules were thrown together to make a space out logistics double module providing more workers to the next store. Space and modules put on the shot 18 times the first and space and missions were thrown. And then how many missions after stop space have been able to deliver to Mir or the International Space Station. Space have also carried experiments to International Space Agency, University of Corporation of Human Experiments,
Nee, das ganze Ding ist ja irgendwie so dieses, die haben dann so Experimente gemacht, aber ich glaube, weißt du, worum es geht? Das ist einfach nur ein Space sein.
Kann man so sagen.